All right, here's a review of the problems. They're just like the ones we have near the end, the last 21, 2, 3, 4, 5, or whatever. All right, so problem 1. You've got a savings account, 6% annually compounded. In your third year, you've got 5,955. Okay, you've got $5,955.08. What was your initial amount? Okay, we'll set up your equation. You've got your final amount here. It equals what? Here's your exponential function. Your initial amount times your rate to the time period. Well, we know everything but your initial amount. Well, this is pretty easy to solve. Okay. I have my initial amount times 1.06. You remember 6%. We're going to convert that to a rate, which is decimal. So that would be 0.06, and we add it to 1. 1 plus our decimal rate. This whole thing gives us our growth rate. So initial amount times 1.06 to the third power equals this. So the only thing we have to do is undo this multiplication, divide both sides by 1.06 to the third, and I get $5,000. That was my initial amount. Okay, so that's how you solve for initial amount. Set up your equation. A times rate to the third power or to the fourth power, whatever t is. Divide by this quantity here, and we get A. All right. Second problem. I've got $15,000, and it grows to $15,600 in year 1 and $16,224 in year 2. Find the interest rate. Well, basically, here's my sequence: 15,000, 15,600. Here's my term 1, 2, 3. I take term 3 divided by the previous term. That should equal the same 15,600 divided by the previous term, and it's all both this and this is 1.04. Okay, so that's our growth rate, but what's the actual interest rate? Okay, so this is what our growth rate is. You know, in our A times B to the X, that's our growth rate, but it really comes from what? 1 plus R, and we need to find out what that actual interest rate is in just a percentage. So 1.0, we're going to go backwards. We'll take 1.04, subtract the 1, and get 0.04, which is, now we're going to go the other way, and that's 4%. Okay? So the interest rate that our money had was 4%. Okay? That's kind of going backwards to just to, get that initial rate. Okay? So just take this divided by the second term divided by the first, the third divided by the second, we get 1.04. Subtract 1, it gives me 0.04 decimal rate, convert it to percent, and go the other way and get 4%. All right? Third problem. Write and solve. After 15 years, what is your balance if your initial deposit was $11,000 at 6%? Okay, pretty easy. Here's my initial amount A times my rate to the T. Okay, at 6%, that's 0.06. Okay, and we're going to add a 1 to that. So $11,000 times 1.06 to the T. Well, what is T? Oops, 15 years. I kind of made a bonehead move there. So I put in 11. So let's just make this 11 years. I had 11 on the brain here. Okay. So all you got to do, here's your 11,000 times 1.06. Plug in for T and plug in the right amount. Don't I just did? So it should be 15. I used 11. I got this value. So all you got to do is plug in for T. Okay. All right, that shouldn't be too hard, even though I messed up. Let me go back here for a sec. Clear that up. Okay, I'm glad I caught that. All right, fourth problem. Any principal, your initial amount here, that's your principal. Okay, I could label that P. Any principal takes 15 years or at 5% to double. That's what we've been discovering. We found out that 5% it takes us 14.2, and it rounds up to 15, about 15 years to double. How long to triple? Well, we've covered this, right? Here's my principal. I used A for initial amount, and here's tripling becomes 3 times initial amount. So here, my initial amount, you can call it P or A, I don't care, times at 5%, my rate is 1.05. 1 plus that 5% in decimal form is 1.05 to the t power. Here's my A times B to the x, exponential function. We don't know A, and it doesn't really matter, okay? How any principal, because it doesn't matter. It could be 10,000, whatever, but it's this initial amount becomes 3. We want to know how long it takes for this to be 3 times that amount. Okay, to be P would be 3P. This would be 3P. So I'm going to take this initial amount. How long does it take to become 3 times that? Okay, and we've kind of covered this very thoroughly. I want to solve for this. I want to get this by itself because this is my term with the variable. So I'm going to undo that and get rid of this A, and we divide both sides by A, and that cancels out. And I'm left with 3 equals 1.05 to the t power. Okay, we need to solve for this t. So the next step is we take the log of both sides. I use natural log. You can use log, common log as well. Okay, but whatever you use, you stick with it. So I use natural log on both sides. This allows this to come, the t, when I take the log of this, the exponent comes down in front. Okay, it can be in either format, but they have the same value. Okay, so now I've got t times the log of 1.05 because we get rid of this and this moves down here. Okay, so t times the log of 1.05. So by taking the log of both, t comes down in front. So now I've got log of 3 equals 2 times the log of 1.05. And now to get t by itself, we just divide by log of 1.05 to both sides. And this right here will give us 22.52 years. That's how long it's going to take to triple our money at 5%. Okay? So we'll have our money tripled at 5%. Okay? Again, anytime you're going to double, triple, if I wanted to double my money, this would be 2A. A becomes 2A. Okay? And then we divide both sides. The A's cancel out, and I got 2 equals this. We take the log of both sides, divide out, and so on. Okay, so we've done that in class. You guys should all have that down. Okay, we need to get this term by itself, divide both sides by A, and I get 3 equals this. We take the log of 3 equals log of this, and the t comes down, and then divide by, that's gone, it's down in front. We divide by this log of 1.05. The log of the rate, log of 3 divided by log of rate equals your t. Very easy. All right, last one. We got 8 minutes. I'm trying to get done. All right. Yeah, that's it. So when we go on to the next lesson, we're going to start doing some things, and we've done this already. So this is a review. Our amount as a function of time of our money equals our principal, the initial amount that we deposit. And this time it's no longer an annual rate. It's going to be 1 plus our rate adjusted for a compounding period. Okay? And then we're going to raise it. This rate here is, again, n times t is how many times we're going to figure out that compound this interest. Okay? So if it's yearly, so let's just take a look. R is a decimal rate of 6%, let's say. We convert to 0.06. Okay, so we'd have 0.06. All right, N is the compounding per year. How many times? So 1 would be annual, so 0.06. So if it's 6%, it's 1 plus 0.06. And if it's annual, N is 1. And if we want 5 years, be 1 times 5. Okay, if it's semi-annually, that's every 6 months. So 1 plus 0.06 over 2. And if we did it for 5 years, that would be 2 times 5 would be compounded 10 times. Now it's very close to just an annual rate. Okay, notice we're going to come 5 years. what you have to realize is we changed this rate. I divided like 6%. I divided it by 2 for a semi-annual. So it would be 3% or 0.03. So the rate is lowered, but we compound it. 2 times 5 would be 10. Okay? So we're going to multiply the principal times 1.03 10 times, which is very close to what 1.06 5 times. Okay? So 1 plus r over n to the nt. N is your compounding period. We adjust the rate. All right? I'll give an example here. Okay? So our growth rate, let's say it's 8% annual, and we're going to figure out our money. We're going to compound our interest quarterly, which means 4 times a year. Okay? So our R is 0.08. But notice 8% per year means we're going to divide that. How many? That's my N. Quarterly is 4 times a year, every 3 months. Okay? All right, so it's 2% a quarter. Okay? So every 3 months we get 2% interest, but 2% times 4 quarters per year is 8% annual. Okay? It just so happens, you know, we're not going to 8% a quarter would be 32% a year. So we have to, if we're this 8% for the year, and we're going to figure out interest quarterly, we got to break up that interest into even quarters. 8% divided by 4 is 2%, or in this case, 0.02. Okay, so here's my principal, and it's going to grow at 8% annually, but compounded quarterly. So I convert this to decimal. I plug it 0.08 here over 4. 0.08 over 4 is 0.02. So 1 plus 0.02 basically is 1.02. Okay. All right. So if I'm going to figure my interest out for 5 years, all right, this is where we have to know the difference. Is that okay? It's to the NT. Well, what was N was quarters, right? So we're going to go for 5 years, right? But how many quarters in a year? There's 4 quarters in a year, so we're going to have 20 compounding periods in 5 years. But it's also at that adjusted rate, okay, at 1.02. All right? So this is interest that is adjusted for a compounding period. It's no longer just simple annual, okay? All right? And this, we have to raise it to how many times we're going to compound it. So if it's quarterly and it's 10 years, it'd be 4 times a year for 10 years. That'd be 40, okay? Boy, I'm taking longer than I wanted. So at 5 years, notice the difference here. There's annual. Principal times 1.08, and the interest is annual. So for 5, we're going to figure out 5 times, compound our interest 5 times. And this is every year we do our interest. So $10,000 times 1.8 to the 5th power is 14,693. Now let's do it quarterly. Okay, so notice how I adjusted this rate. 0.08 divided by 4 got me this rate here. It's a smaller rate, but notice I'm going to figure it out 20 times because it's 4 times a year times 5 years. So now it's 20. Okay, annually 5 years it's just 5. Quarterly it's 4 times a year. 4 times 5 is 20. So 10,000 times 1.02 to the 20th power is 14,859. So this is greater than that by about close to $200. So this is why compounding more often is beneficial. By quarterly, the interest builds faster, and you're taking interest. You add the interest more often. You take interest on top of interest. So it ended up being about $150, $160 more, which matters. Okay, so that'll help us out in the next lesson. Okay, that is it. 14 minutes. See you tomorrow. Good luck on the test. Take good notes.